Welcome to section 6.1 and 6.2. We're going to be doing these two sections today in one because we're all dealing with the same type of thing. And then what we're going to do is spend 2 days working on the homework and kind of perfecting the idea. So let's start with topic number 1. What is an nth root? Well, if we see that a base to the nth power equals a, and so this is the exponent rules that we did in chapter 5, what you can say is that there's an nth root. And this is the idea. Now we're going to also pop up our calculator at points and times along the way so that I can show you how to use your calculator. But the way we say it is the nth root. Okay? So you'll have the square root is 2, cube root is 3, and then it goes 4th root, 5th root, 6th root, 7th root, things like that. Okay? Now, as we go through, we're going to take a look at the first example. I know that if x to the 5th is 1024, if I want to find the value of x, to get rid of a 5th power, we take a 5th root. Okay, so we're going to take the 5th root of both sides. Well, if I take the 5th root of x to the 5th root and the 5th power cancel out. And then if I take the 5th root of 1024, I'll get my answer. Now I'm going to say the answer, and then what I'm going to do is show you how to get that in your calculator. So what we're finding then is x equals 4. Okay, now give me a second, let me pull up the calculator. If I slide this over, let me move this a minute. We want you to look at this 5th root. So I'm going to turn this on. Now if you go to your math function is where you find the roots. And so if you look at this right here is the cube root. And then the next one, 5, is the one we're going to use the most. That's for any other root. So the way this works, and I'm going to have to turn this off for a minute, but the way this works is if we want to take the 5th root of 1024, what we'll need to do is clear out of this a minute. We'll take 5 and then go to math and then down to that x root. And so this says take the 5th root of 1024. And you'll notice you don't need parentheses with the x root because it's assuming whatever comes after that is what you're taking the root of. And we press enter and that's how you get 4. Okay, so some of these as we go through and we have to evaluate them or check them, we'll use our calculators. So I just want to show you first. Now for the first grouping here, topic 2 and 3, we don't need our calculator, so I'm going to minimize this for a second and I'm going to bring up my topic stuff again. What we're trying to get you to do in topic 2 and 3 is just show the comparison between how a root and an exponent are connected, okay? Now, a square root, if you look at this first one, a square root is the same thing as the 1/2 power. So it's x to the 1/2. So in a reciprocal, or basically a fractional exponent is the same thing as a root. So the cube root is the same thing as the 1/3 power. If I look at the third one, I was going to go across. They want to take the 4th root of 3. Now, I don't want to find the answer. I just want to rewrite it. So 3 is my base, and because it's a 4th power, it's the 1/4 exponent. Now, the biggest thing is that you need to keep in mind when you do this that your exponent needs to be small enough that I know it's an exponent. Okay? Now, we're going to get a little harder here. We have a square root outside. If you want to put in a little 2, you can, but we have the square root outside, and we have a 3rd power on the inside. So I'm going to rewrite this as 5 cubed, and then to the 1/2 power for the square root. Now, according to exponent rules, if you remember back from chapter 5, I take these two and I multiply them together. 3 times 1/2 is 3/2. We do not want our fractions, our exponents, to be mixed fractions. So I don't want to say 1 and 1/2. I want to leave it as a simple fraction. Okay, so we're going to keep going. If I look at the next one, it's x to the 5th, and then you have a third root, which is the 1/3 power. So if you put this as 5 over 1, we know we multiply the top to get 5 times 1 is 5. We multiply the bottom, 1 times 3 is 3, so it's 5/3. And that's what's happening with the one previous as well. Let's go one more. I take x squared and I raise it to the 1/4 power because it's a 4th root. Now the only thing I'm going to ask is, can this be simplified? Well, 2 times 1/4 is 2/4, so it's x to the, and I'll write the 2/4, but we know 2/4 can be reduced to 1/2. So if you can reduce the exponent, you should, because that'll help us simplify things along the way. Okay, let's go a couple more. This is x to the 9th, and then it's the 3rd root, so it's the 1/3 power. Well, 9 times 1/3 is 3, so it's x cubed. Let's keep going. 10 to the 8th power, and now this doesn't have a number, which means it's a square root. If you feel the need to put a 2 in there, that's fine. A square root is the 1/2 power. 8 times 1/2 is 4, so it's 10 to the 4th. And again, as of right now, I don't want to simplify these. I just want to leave it as is, but I want at least to see the idea. Last one in this section, I have x to the 7th power, and because I have the 7th root, I raise it to the 1/7. 7 times 1/7 is 1, so it's just x. Now, if you want to put an x to the first in and then say that's x, that's fine. But we don't want to see the exponent of the 1 there because it's just signifying as an x. Now, here's what I'm going to do. I'm going to change my color a minute so that we can kind of point this out. But if you take a look, we want to make sure that you understand that the root, okay, the square root, cube root, 4th root, is in the denominator of our exponent. So if you look, our denominator, like here, 3 was the root that was outside, okay? Or 2, it was a square root outside. And so we want you to keep in mind that denominators of exponents are the roots. And that's important because we're going to now ask you to go backwards. Can you now take a fractional exponent and make it the root? So I'm going to look at this and I say, well, there's a 3 on the bottom, so it's going to be the cube root. And the question is, if I take away the 3, what's left? X to the 4th. Okay, now I'm going to jump around on a couple of these because some are easier than others. I'm going to jump to the third one over, x to the 12 over 8. We know that 8 is our root, so 8th root of, and what we have left is x to the 12th. And at this point in time, they don't want you to simplify that. They're just saying, can you rewrite it? Okay. Let's do another positive one. Let's go to this one down here, 20,736 to the 1/4. The 4 is the root, so we're taking the 4th root of 20,736. Now, do we need to say to the first power? The answer is no, so we leave our answer there. Excuse me. Now, let's talk about negative exponents. If we remember from chapter 5, negative exponents mean we take reciprocals. So if it was a whole number, like the one 2 to the negative 2/5, if it was a whole number, it's now going to make it a fraction. So it's now 1 over, that's what this negative does, that negative makes it a fraction. And then I do the same thing as I did before. 5 was the root, so the 5th power of 2 squared. And the negative basically goes away when we make it a fraction. Okay, so let's go, I'm going to do the 64 one first. The negative again makes it a fraction, so it's going to be 1 over. Then I look at my root and I say 3, so the cube root. And then I look at what's left. The 64 I didn't use and the squared I didn't use, so it's 64 squared. All right, last one in this section. If the negative exponent is on bottom, then it's going to move it to the top. So I'm now going to no longer have that fraction of 1. So if I look, I have the 4th root, so the 4th root of 84, and then I have the cubed left. And that negative takes care of the fraction. And then what I'm left with then basically is looking at 84 to the 3/4, and I make it a root. Okay? And so this is the idea. If they want you to work backwards, they don't want you to simplify anything, they just purely want you to rewrite it. So far all we've done is taken a root to an exponent and an exponent to a root. Now, one thing I put on here is this homework help section. When you get to your homework numbers 1 through 11 in 6.1, if you get stuck and aren't sure what to do, you should be looking here at topic 2 and 3 to kind of help. And so I tried to put these markers in case you looked at it and said, whoa, when I do my homework, I'm not going to remember this. This is kind of my way of helping. Okay, so let's go down and look at topic number 4. If you look at topic number 4, it talks about the number of possible outcomes when you take a root. Positive numbers have both positive roots and negative roots. Okay. Oh, I'm sorry, I'm looking at my wrong notes. Let me try that again. I apologize. I was on the wrong section. Let's try that again. Positive numbers have both even roots and odd roots. Now that I've screwed you guys up, let me explain what that means. I'm asking you in this first example to take the 5th root of 243. Okay, so I'm going to put in my calculator the 5th root of 243. And if I do that, which let me go with you real quick and show you. If I go back to my calculator, I go 5, back to math, and I want that x root, which is number 5, the 5th root of 243, and I get 3. Okay? Now here's what this says. This says that if I multiply 3, 1, 2, 3, 4, 5 times, I should be able to get 243. Okay? If I look at the second one, we're saying the 4th root of 81. So let me do that a second. The 4th root of 81 is also 3. What that says is if I take 3 and I multiply it 4 times, I should get 81. So I'm looking at this going, okay, I'm basically working backwards and saying what to the 4th power gives me 81. Okay, so we're going back a little bit differently in chapter 5. Now, when it comes to a negative number, you can only have odd roots. You can only take a 3rd, a 5th, or a 7th power root, or 7th root in order to find the answer. And let me show you. It says in number 1, take the cube root of negative 216. Okay, so I go to my calculator and I take the cube root. Oh, I don't need the 3. Let me show you. Number 4 is the cube root of negative 216. I'm going to close my parentheses. What you find is it's negative 6. So here's what it says. I take negative 6 times negative 6 times negative 6, and I'll get negative 216. If I try to do an even root, if I try to take the 4th root of negative 64, let me show you what happens. 4th root of negative 64, it says non-real answer. And let's talk about why. What it's asking is, can I take something and multiply it 4 times and still get a negative number? Well, if it were positives, a positive times a positive is positive, times a positive is positive, times a positive is positive. So my answer couldn't be a positive answer. Our thought is the answer should be negative. But we know that if we group negatives by 2's and multiply them, we're going to end up getting positive answers. And so what they're saying is you cannot multiply a positive or a negative an even amount of times and still get a negative answer. Your calculator will help you with that. If you see non-real, then it's not possible is what we're going to write for our answer. But I just want to keep in mind as to why that is. You cannot multiply an even number of times and still get a negative. Okay? So let's flip a page. We're going to use our calculators a little bit more as we go through. So I'm going to slide this down, and we're going to evaluate and simplify. The hardest part about this is the fact that we're not going to be using a decimal. Okay? Now, those of you that would like the extra challenge, please try these without your calculators if you can. It really would test your exponent rules, but let's take a look at a couple of them. Okay? And this mixes in a bit of section 6.1 and 6.2, and so I'll kind of show you here. It looks to me like, if I can keep this straight, numbers 1 through 5 are from 6.1, and numbers 6 through 10, I believe, are from 6.2. Okay? So to kind of keep in mind as to where things are coming from. So let's take a look. We are going to ask you to evaluate these, but you can't have a decimal. So your calculator will come in handy a little bit, but not a ton. Let's start by rewriting like we did on the front. This negative exponent here says that I'm going to have a fraction. So I'm going to have 1 over, and then I look at this denominator, the cube root of negative 125 squared. Now let's talk about how to do this first. Is it easier to take the cube root of 125 or to square 125 without the use of your calculator? And the answer is to cube root, because I'm asking what cubed gets me 125. And here's what ends up happening. The cube root of negative 125 is negative 5, and we're going to take that answer and we're going to square it. So what you end up getting is an answer of 1 over 25. Now, calculator-wise, let's look at that a minute. Where's my calculator? If I look at this, I want to take the cube root of negative 125. That's what we did first, is we cube rooted that. You got negative 5. And then we asked you to take negative 5 and square it, and you got 25. Because the exponent is negative, it's going to be 1 over 25. Excuse me. So let's look at the next one, and I'm going to kind of write on this a bit. If I look at 36, I'm going to write just below it so that you guys can still see. I'm going to take the square root, so the square root of 36 cubed. Now you can do this in any order. Which one do we know? Well, we know that the square root of 36 is 6, and then we could take 6 cubed and get 216. Okay, so here's the moral of the story. If you're using your calculator, is fine. I'm going to show you how to do that one in the next. But if you can do this without, you're going to be better served, and it's always better to use the root first, and then whatever your answer is, get the exponent. Okay, so let's look at our calculators, because let's be honest, most of us are going to. In number 3, I'm going to plug this in directly as it's shown, okay? So I'm going to start with, as I go through this, negative and then parentheses, 625, and then I got to raise an exponent. Now, because my exponent is a fraction, I'm going to need to put that in parentheses as well. So 3 divided by 4. Close that. Now that closes, if you look at it, it closes my exponent, but I got to close it one more time for my entire problem, and I press enter. Now you'll notice I get an answer then of negative 125. The only thing I caution you on is doing some of this will give you decimals, and sometimes your math fraction button won't work, so you might have to do the root first. But let's try one more. If I look at number 4, I'm going to put it in as it shows. Negative 32 raised to the, and because 2/5 is a fraction, I'm going to put 2/5 in parentheses. And then I'm going to press enter, and what you find is that you get an answer of 4. Okay, so this is the general idea when we ask you to evaluate. And as we go through and evaluate, these are the type of things that, again, can be done on your calculator, and I understand that. Okay, so let me clear out of this a minute, and I'm going to move this over and see, because we shouldn't need our calculators anymore. So let's go through number 5. Now you'll notice I have an exponent, x to the 2/5, and then I also have a square root. So I'm going to rewrite this, x to the 2/5 to the, and the square root is the same thing as the 1/2 power. Because in chapter 5 we remember we multiply exponents. If I multiply the top, I have 2 times 1, which is 2. If I multiply the bottom, 5 times 2 is 10. Therefore, I can reduce my fraction to x to the 1/5. Okay, and we're kind of simplifying as we go. Number 6, if we remember back to exponent rules, we divide quotients, we subtract their exponents. So we're taking 7/5 power minus the 4/5 power. And if we talk about common denominator, since the denominators are the same, we can subtract the numerators. So this is x to the 3/5. And when all possible, we'd love for you to go back and say the 5th root of x cubed. Okay? So kind of keep that in mind as you're going through. Let's do number 7. We multiply the exponents. So you get x to the negative 6/5. Now, negative exponents, then say, put it in a fraction, so it's 1 over x to the 6/5, which if I put this in a root form is 1 over the 5th root of x to the 6th. Now, normally if they start you in a fraction, then you can end it in a fractional way, like 1 over x to the 6/5. But I like to go back to roots whenever possible. Okay? Now, number 8, you know what? Number 8 I want to save for class. Okay, because we're going to need to go through a couple of these types. And actually, oh, not for class, there's some at the bottom. Let me get rid of this. So I will do number 8 when we get to the ones at the bottom. Okay? So let me do the last couple of things. You'll notice these are common terms or like terms because they have the same exponents. So there's 4 of those plus 1 of those makes 5 of those, x to the square root of 3. Pretty simple. In number 10, though, I can't add these together because I don't have a common square root. But if I remember back to chapters 4 and 5, I can break down my square root of 45 to be the square root of 9 and the square root of 5. Therefore, I have 5 square roots of 5 from my beginning, plus the square root of 9 is 3, so 3 square roots of 5. And 5 square roots of 5 plus 3 square roots of 5 equals 8 square roots of 5. Okay? So this is a bunch of simplifying of things as we go through. Again, if you need help with any of your homework, take a look at this homework help, and it'll tell you kind of questions to look for, so that when you get to a section, you kind of have an idea as to where you're trying to look. Okay? Let's take a look. I'm going to X out of here. Let's go back to solving now, and this is the one that's going to seem the nicest because you're used to it. We're going to solve equations, And if you remember, solving equations means that you do PEMDAS backwards. So please excuse my dear Aunt Sally. Okay? So I'm going to look at each equation. In number 1, do I have addition or subtraction? The answer is no, so I go to the next one. Do I have multiplication or division? Well, I have a multiplication of 2, so I'm going to get rid of that by dividing both sides by 2. So x to the 6th equals 729. All right, to get rid of a 6th power, we take a 6th root. Okay, so I take a 6th root, and I'm going to put this in my calculator, and I'm going to say the 6th root of 729 excuse me, sorry, equals 3. So when I look at this, I get 3. Now, the only problem is, if you remember back in chapter 4 and 5, when we solved things with roots, like a square roots have 2 answers. So even roots need the plus and the minus. Like a square root, a 4th root, a 6th root, they all act the same way. So this should say positive 3 or negative 3. So you're going to have 2 solutions here. Okay? Now, while I can see number 3, let's look at number 3 a second. If I look, I have multiplication of 1/2. So I'm going to multiply by its reciprocal of 2. So x to the 5th equals 1024. And in order to get rid of the 5th root, I take the 5th power, I take the 5th root. And again, you can plug this in your calculator, but the 5th root is 4. Now, the reason I don't have 2 answers is because odd things can't equal, you won't have negatives in there, because if I multiply them 5 times together, it'd still be negative. Okay? Now, let me get rid of my calculator a minute. Let me go back up to number 2. I have parentheses, but there's an exponent outside first. So to get rid of a cube, I have to take the cube root. X plus 4 equals, I now have the cube root of 12. Unfortunately, the cube root of 12 gives me a decimal, and I don't want a decimal, so I'm going to leave it. I'm just going to finish solving by subtracting 4. And the way we write this is negative 4 plus the cube root of 12. Now, if they ask you for a decimal, you could put that in your calculator and get a decimal. But at this point in time, let's just leave it there. It's a little bit easier. Okay, last one for solving. I have addition and subtraction, so I'm going to get rid of the 34 first. X to the 6th equals 215. Make sure I have the right number. To get rid of a 6th power, I take a 6th root. Because it's an even root, my answer is going to be plus or minus. The problem is when you put 6th root of 215 in your calculator, you get a decimal. So we're going to leave this as the 6th root of 215. Not pretty, but I like that better than a decimal answer. Okay. Again, if you need homework help questions, if you're trying to solve, take a look at the type of questions that you can find there for extra help. Now, topic number 7, in my opinion, is the hardest because it's a little bit more abstract. Okay, we're not just doing the algebra, we're not just solving, we're actually trying to kind of break this up. So here's what's going to happen. This is like the one number 8 above, but if you look, I'm asking you to take the square root of 64x cubed. I'm going to split this apart like I have square roots before, and I'm going to say the square root of x to the 4th, or 64, and the square root of x cubed. Okay. Now, the square root of 64, we know, is 8. So that's the nice part first. Okay, the second part is the harder part. a square root has an exponent of 2, right? It's a root of 2. And so we want to take this and break it into chunks of 2. So I have x squared and a single x, because x squared times x gets me x to the third. Well, if I take the square root of each of those, and I don't want to put that 2 there, but if I put the square root will cancel with a squared and just leave me with an x. Can I take the square root of a single x? No, because I don't know what x is. So my answer is going to be 8 times x with a square root of x. Now, to you guys, I know that doesn't seem any better, but trust me, when we go to start solving things, that will be much nicer. Okay, now let me go a little harder. There are 3 things. So I'm going to split this up in 3 ways. I'm going to do x's, y's, and z's. So I have the cube root of x cubed. I have the cube root of y to the 4th. And I have the cube root of z to the 7th. Okay, now, as I look at x's, we're going to take one at a time. If you notice, I have a cube root and a cube. Those cancel out. I'm just left with an x. In the second one, I want to, because the exponent is bigger than 3, I want to break this up into a chunk of y cubed, and then I've got one more y left over. Let me try and make this a cubed. So if I cube root each of these, if I cube root y cubed, this goes away, I get a y. This one is still left as the cube root of y, because the 1. Now your goal is to get the exponent less than the root, okay? In the z's, how many chunks of 3's can I split this up to? Well, I can do z cubed, and I can do another z cubed, that makes 6 of them, and I can do one more z, which makes 7. So 3, 6, 7. Now I cube root each of those. Cube root and a cube cancel, so this gives me a z. Cube root and a cube cancel, this gets me a z. And this one I can't touch, so I leave it as the cubed root of z. Now, the way this works, let me take a different color a minute. The way this works is anything without a cube root goes together. So x, y, and I've got z times z, which is z squared. So x, y, and a z squared all come out front. Now I'm going to put in a times because we're taking a cube root. Now the roots then will go together. So I'll say the cube root, and I have left underneath the root a y and a z. And this is simplified, although, again, to you guys it might not seem that way. These are going to be the harder questions, but once you get the general idea, it's pretty much like doing the same thing over and over again. But those will be something I will make sure is on our warm-up so that we can practice that a little bit more. So that's the end of 6-1 and 6-2. Again, we're going to be working on 6-1 tomorrow in class, and then the next day we'll work on 6-2 just to get us kind of ready. At some point in time, we'll give you a little mini quiz too on this, these 2 sections. So, thanks for watching.